Did a message just appear from a blank piece of paper? Did a statue just bleed? Did a disembodied head just whisper a prophecy? To someone living in the medieval period, the answer was simple. It was magic. It was the work of spirits, demons, or God himself. The world was full of unseen forces, and some people knew how to command them. But what if they weren't commanding spirits? What if they were just commanding physics? What if their secret incantations were just chemical formulas? The line between science and sorcery was not just blurry back then. It did not exist. The scholar, studying the reflection of light, was a natural philosopher. A street performer using that same knowledge to project a ghostly image was a magician. An alchemist heating mercury to see what happened was an investigator. When he mixed it with sulfur and created a brilliant red powder, he was a miracle worker. We look back and see science. They looked around and saw enchantment. They saw a world governed by sympathies, omens, and hidden properties. And a few clever people used this worldview, combined with a bit of secret knowledge, to create effects that seemed impossible. They weren't fakes. They were just ahead of their time. They were the scientists of an age that did not believe in science. They were the magicians. And their tricks were so good, they have been fooling people for centuries. So, how did they do it? How did they make fire burn on water and make metal objects move without touching them? Number 19, could a head made of brass really predict the future? The legend is a good one. A friar, brilliant but feared, locks himself away for 7 years. He is trying to build a talking head. A head made of brass that will answer any question, predict the future, and reveal the secrets of the universe. The friar is Roger Bacon, a real 13th century scholar. His creation is the brazen head. The story says he finally succeeded, with the help of a demon, but he and his assistant fell asleep from exhaustion. The head spoke 3 times. Time is, then, time was, and finally, time is past. And with that, it shattered into pieces. The chance was lost. It sounds like pure fantasy. But the idea of a speaking statue was not just a myth. It was a very old form of magic that relied on a simple science. In acoustics, the study of sound, long before Bacon, hero of Alexandria, an engineer in the 1st century AD, designed talking statues for temples. Priests would use them to deliver divine messages to awestruck worshippers. The method was simple. A speaking tube, a pipe, was hidden within the statue. It snaked through the walls and floors to a hidden chamber. In that chamber, a priest would speak into the tube. His voice would travel along the pipe and emerge from the mouth of the hollow statue. To the person standing in front of it, the idol of a god was speaking directly to them. Roger Bacon was a real person, an English philosopher and Franciscan friar, who placed a huge emphasis on empiricism and experimentation. He lived from around 1219 to 1292. He was a man far ahead of his time. He wrote about optics, gunpowder, and the possibility of flying machines and horseless carriages. His book, the Opus Majus, was a revolutionary plea for a new way of learning, one based on observation, not just repeating old texts. But this focus on the physical world made people nervous. To his contemporaries, his experiments looked a lot like sorcery. The legend of the Brazen Head was likely a story cooked up by his rivals to discredit him. It painted him as someone who trafficked with demons, not someone who studied the laws of nature. So, did he build a real brazen head? Almost certainly not. But he was fascinated by automata, or self-operating machines. And he definitely understood enough about acoustics to know how such a trick could be pulled off. The legend was powerful because it played on a real possibility. Maybe he did not summon a demon. Maybe he just had a clever assistant and a well-hidden tube. The magic was not in the brass. It was in knowing how sound travels. This trick taps into a deep human desire for hidden knowledge. The idea that an object can hold ancient wisdom is powerful, but the science shows us the wisdom often comes from a clever person in the next room. It is a trick of engineering, not enchantment. What we still do not know is unsettling. How much of the Bacon legend was just a story, and how much was based on a real, misunderstood prototype he might have built? Could such a simple acoustic trick really have fooled the most educated people of the 13th century, or was the belief in magic so strong that they were willing to overlook the obvious? And if a simple tube could be so convincing, then what modern technological magic are we failing to question today? Number 18, how could fire burn on water? Imagine a fleet of wooden ships attacking a city from the sea. As they draw near, the defenders unleash a stream of liquid fire from a great nozzle. The fire hits the enemy ships, it sticks to the wood, it sticks to the men. And when the sailors jump into the water to save themselves, the water itself catches fire. There is no escape. The fire burns on the waves. This was not a scene from a fantasy novel. This was Greek fire. It was the secret weapon of the Byzantine Empire for centuries. It was first used around 672 AD during the Arab sieges of Constantinople. Its effect was devastating both physically and psychologically. It was a weapon that defied the laws of nature. Fire and water were opposites. One was supposed to extinguish the other, but this fire was different. It was considered a divine miracle, a gift from God to protect the Christian empire. The formula was a closely guarded state secret passed down from one emperor to the next. Losing the formula was unthinkable. The magic was in the chemistry. While the exact formula was lost with the fall of Constantinople, historians and scientists have pieced together the likely ingredients. The base was almost certainly crude oil or naphtha, a light petroleum liquid. This gave it its sticky, burning quality. To this, they likely added other substances. Sulfur would make it burn hotter and produce choking fumes. Pine resin would help it adhere to surfaces. But the key ingredient, the one that made it so terrifying, was probably quicklime, also known as calcium oxide. Here is the science. When quicklime gets wet, it undergoes a powerful exothermic reaction. That means it heats up, and it heats up a lot, very quickly. It can easily reach temperatures high enough to ignite the petroleum mixture. So the moment the Greek fire mixture hit the water, the quicklime would react and cause it to burst into flame. The oil base, being less dense than water, would float on the surface, creating the horrifying illusion of the sea itself burning. The weapon was deployed using a siphon, a large bronze tube that used a pump to shoot the liquid. It was essentially an early flamethrower. The psychological impact cannot be overstated. An enemy navy would be facing not just a weapon, but what they believed to be a supernatural force. It created panic and terror. The Byzantines cultivated this belief. They knew the fear it caused was as powerful as the flames. The weapon's success in defending Constantinople multiple times, especially in the sieges of 717 to 718, cemented its legendary status. The science was simple chemistry, a mixture of flammable liquids and a chemical that reacts with water. But in a world without a periodic table, without a concept of chemical reactions, it was pure, terrifying magic. But what do we still not know? Was the formula ever written down, and could a copy still be hidden in some forgotten archive? How did they develop a pump system robust enough to project the volatile liquid without it exploding on the user? And perhaps most importantly, how many other lost technologies from the ancient world were just simple science that we have forgotten? Number 17, how could a stone make water boil? A performer stands before a small crowd. He takes a bucket of cold water. He asks an audience member to touch it, to confirm its temperature. It is cold. He then holds up a few dull gray stones. They look ordinary. He drops the stones into the water. Nothing happens for a moment. Then, the water begins to hiss. It starts to bubble. Soon, the entire bucket is churning and steaming as if it were over a roaring fire. The performer has made water boil with a stone. This was not sorcery, it was a chemical reaction. The stone was not a stone, it was quicklime. Calcium oxide, the same substance believed to be a component of Greek fire. Medieval and Renaissance alchemists and natural magicians knew about the strange properties of certain materials. Quicklime, made by heating limestone in a kiln, was one of the most dramatic. The science is straightforward. When calcium oxide CaO is mixed with water H2O, it undergoes a chemical reaction called slaking. It turns into calcium hydroxide KO2. This reaction is highly exothermic, meaning it releases a tremendous amount of energy in the form of heat. The heat is so intense that it can easily bring the surrounding water to its boiling point of 100 degrees Celsius, 212 degrees Fahrenheit. The hissing, the steam, the bubbling, it is not the water magically boiling. It is the water reacting to the sudden intense heat generated by the chemical change. This knowledge was written about in texts on alchemy and natural philosophy. Giambattista della Porta, a 16th century Italian scholar, described this very trick in his famous book Magia Naturalis, Natural Magic, first published in 1558. He was not trying to fool people with demonic powers, he was demonstrating the wondrous properties of the natural world. To an uneducated crowd, seeing a man boil water with a rock was indistinguishable from magic. He was controlling the elements. This trick played on the common understanding of the world. Heat came from fire, that was it. To produce heat without a flame was to break the rules of reality. The performer was not just a trickster, he was someone who seemed to have access to a different set of rules. He knew something about the world that others did not, and that knowledge gave him power. He could create something from nothing, heat from a cold stone. The questions that remain are intriguing. Who first discovered this property of quicklime? And was it by accident? Did this knowledge give certain stonemasons or builders a reputation as having magical abilities? And how many other simple, dramatic chemical reactions were kept as secrets by guilds or performers, passed down as spells rather than as science? Number 16, could you really see the future in a crystal? The image is iconic. A fortune teller, a scryer, hunched over a crystal ball in a darkened room. They stare intently into its depths. Their eyes glaze over. They begin to speak, describing visions of the past, present, or future. This practice, called scrying, is ancient. People have used bowls of water, mirrors, polished stones, and crystals to seek hidden knowledge for thousands of years. In the medieval world, it was a serious and often dangerous pursuit, considered by the church to be a form of divination that invited demonic influence. But the visions may not have come from another world. They may have come from inside the scryer's own brain. The magic here is a mix of optics and psychology. The setup is key: a dark room, a single point of focus, the crystal ball. The scryer stares unblinking for a long time. This is where the science begins. First, the optical effect. A crystal ball or a bowl of water acts as a lens. It gathers and distorts the light in the room. It reflects faint, blurry images of the surroundings, like the flickering of a candle or the scryer's own face. The mind, desperate to find patterns, starts to interpret these random, shifting shapes. It is like seeing faces in the clouds, but more intense. This is a psychological phenomenon called pareidolia. Second, and more powerfully, is the brain's own reaction to the sensory deprivation. When you stare fixedly at a single, unchanging point, something strange happens to your peripheral vision. It is called Troxler's fading. Your brain is wired to pay attention to new information. If a signal from your eyes is constant and unchanging, your neurons essentially get bored and stop reporting it. Things in your peripheral vision can seem to disappear or fade. This can create a hypnotic, trance-like state. In this state, the brain can start to produce its own images. These are called hypnagogic hallucinations, the kind of vivid imagery you sometimes experience just as you are falling asleep. The scryer, in their focused trance, is essentially tricking their brain into dreaming while they are still awake. The visions they see are not coming from the crystal. They are being projected onto it by their own subconscious mind, shaped by their fears, desires, and expectations. A famous scryer in the court of Queen Elizabeth I, John Dee, used a polished obsidian mirror to receive messages from angles with the help of his associate Edward Kelly. It is likely Kelly was in a self-induced hypnotic state. The magic is not in the object, but in the mind's response to it. The crystal is just a tool to help the brain unlock its own hidden theater. But this raises some deep questions. If the visions are just hallucinations, why have scryers across different cultures for thousands of years reported similar types of experiences? Can a focused, meditative state truly allow access to information that is not available to the conscious mind? And is it possible that the magic is simply a name for a psychological process we still do not fully understand? Number 15, why did some objects seem to move on their own? Imagine a magician placing two small figures on a table. He speaks a command, and one figure slowly turns to face the other. Or he places a needle in a bowl of water, and it mysteriously swings to point in a single direction, no matter how the bowl is turned. This was sympathetic magic, the idea that objects could influence each other from a distance through a hidden connection. Like it was a core concept in medieval thought, and one of its most potent demonstrations involved a strange stone. The lodestone. The magic was magnetism. The lodestone is a naturally magnetized piece of the mineral magnetite. Its ability to attract iron and to align itself with the Earth's magnetic field was known to the ancient Greeks, but it was viewed as a mystical property. The 12th century scholar Alexander Neckham is one of the first Europeans to describe its use for navigation. By the 13th century, Peter Peregrinus de Maricourt wrote the Epistola de Magneti, one of the first scientific studies of magnetism. But outside of these scholarly circles, the lodestone's power was pure magic. A street performer could easily use it for tricks. A small, powerful lodestone, hidden in their hand or under the table, could make an iron needle or figure move as if by an invisible force. The audience would see an object animated by the magician's will. They would not see the hidden magnet driving the effect. Another classic trick was the sympathetic needles. Two needles would be rubbed on the same lodestone. Then, one would be given to a person in another room. The magician would touch his needle to a letter on a board, and supposedly, the other needle would swing to point to the same letter. This was a complete fabrication, but it was based on the real mysterious property of magnetism that people had already witnessed. They believed it was possible. The lodestone became a symbol of love and attraction. It was used in love potions and charms. The idea was that if this stone could draw iron to it, then a powder made from it could draw a person's heart. This was the doctrine of signatures, the belief that the appearance or properties of a thing revealed its hidden purpose. A magnetic stone must be for creating attraction. The science is one of the four fundamental forces of nature. Magnetism is caused by the motion of electric charges. In a material like magnetite, the spinning of electrons in its atoms aligns in such a way that it creates a persistent magnetic field. It is not a mystical sympathy, it is a physical property of matter. But to a world that could not see electrons, it was an invisible spiritual connection between objects. This leaves us with some puzzling questions. How did early navigators trust their lives to a magical stone that pointed north, a direction associated with darkness and evil in some traditions? Was the belief in sympathetic magic a barrier to understanding the real physics of magnetism, or was it a necessary stepping stone that encouraged people to experiment with it? And what invisible forces are we surrounded by today that future generations will understand as simple science? Number 14, how did statues seem to weep or bleed? In a dim church, a crowd of pilgrims is gathered before a statue of a saint. They pray for a miracle. Suddenly, a single red tear trickles from the statue's eye. Then another. The statue is weeping tears of blood. The crowd falls to its knees. A miracle has occurred. This was a powerful and not uncommon event in the medieval and Renaissance periods. It was seen as a divine sign, a mark of God's favor, or a warning of his wrath. But the blood may not have been blood, and the miracle may have been chemistry. A bleeding or weeping statue was a trick that could be performed with some basic knowledge of chemicals that react with each other or with the air. It was a clever way to inspire faith, or perhaps to extract donations from the faithful. One of the simplest methods involved using ferric chloride and potassium thiocyanate. Both are salts that can be made into a clear, watery solution. An assistant could paint the ferric chloride solution onto the statue's eyes beforehand. It would dry and be invisible. The performer or priest would then touch the statue's eyes with a sponge or cloth that had been soaked in the potassium thiocyanate solution, perhaps hidden in their hand during a prayer or blessing. When the two chemicals touch, they react instantly to form iron thiocyanate, which has a deep blood red color. To the observer, it looks exactly like the statue has begun to spontaneously bleed. Another, even more subtle method relied on a chemical's reaction to air. A substance like phenolphthalein mixed with a base is bright pink or red. But when exposed to carbon dioxide in the air, it slowly becomes clear. A clever person could reverse this. A solution of phenolphthalein and a weak acid would be clear. They could secretly apply this to the statue. Then, they could release a hidden source of ammonia gas nearby. As the alkaline ammonia gas wafted over the statue, it would react with the clear solution, turning it a startling red. The blood would appear from nowhere. These tricks were known to alchemists and natural magicians. The book De Secretis Mulierum, On the Secrets of Women, a popular text falsely attributed to Albertus Magnus, contained all sorts of recipes and chemical tricks. While some priests were undoubtedly sincere in their belief, others may have used this hidden knowledge to bolster the faith of their flock. This was not always seen as deception. In a world where God worked through nature, creating a miracle by using the hidden properties of that nature was not necessarily a lie. It was simply helping God reveal himself. The science is basic acid-base and precipitation reactions. But the effect is profound. It turns an inert object of wood or stone into something that appears to be alive and feeling emotion. It bridges the gap between the physical and the spiritual. This leads to some uncomfortable questions. How many historical miracles were actually clever chemical demonstrations? Was this knowledge widespread, or was it a closely guarded secret among a select few? And if People's faith was strengthened by a fake miracle? Does that make the faith itself any less real? Number 13. How could a person walk on fire? The trial by ordeal was a common practice in the early medieval period. An accused person's guilt or innocence was determined by a dangerous test. One of the most dramatic was the ordeal by fire. The accused had to carry a red-hot bar of iron for a set distance or walk barefoot across burning coals. If their wounds healed cleanly after a few days, they were innocent. God had protected them. If the wounds festered, they were guilty. Later, firewalking and fire eating became the domain of street performers and mystics who claimed to have supernatural protection from the flames. They would handle burning torches, hold hot coals in their mouths, and walk across beds of embers, all without apparent harm. To the audience, this was a display of incredible power over one of the most destructive elements. The magic here is physics, specifically the principles of heat transfer and a phenomenon called the Leidenfrost effect. Firewalking is not about having fireproof skin, it is about understanding how heat moves. First, the coals themselves are important. Wood is a poor conductor of heat. While the embers are very hot, they do not transfer that heat to another object very efficiently. A piece of metal of the same temperature would cause a severe burn instantly because metal is an excellent conductor. Second, the contact time is crucial. The firewalker does not stand still. They walk quickly and steadily across the coals. Their foot is only in contact with any single ember for a fraction of a second. This is not enough time for a dangerous amount of heat to be transferred. The most fascinating part is the Leidenfrost effect, first properly described by Johann Gottlob Leidenfrost in 1756, but certainly exploited much earlier. This effect happens when a liquid comes into contact with a surface that is significantly hotter than the liquid's boiling point. When the firewalker's foot, which is naturally moist with sweat, touches a hot coal, a thin layer of that moisture instantly vaporizes. This creates a tiny insulating cushion of water vapor between their skin and the coal. For a very brief moment, their foot is not actually touching the hot surface. It is floating on a layer of its own steam. This same effect is what allows a fire eater to briefly hold a flaming torch in their mouth or extinguish it on their tongue. The moisture in their mouth creates that protective vapor barrier. So, the magic is a combination of using a poor heat conductor wood embers, minimizing contact time, and relying on the insulating properties of water vapor. It is a trick of physics, not a miracle from God, but we are still left wondering. Did the priests who administered the ordeal by fire know about these principles, and did they sometimes prepare the accused's feet with certain substances to increase their chances of passing? How many people were wrongly convicted or executed because they did not walk quickly enough? And could the intense psychological state of the firewalker, their belief and focus, actually have a physical effect on their body's response to the heat? Number 12. How could a lamp burn forever? Legends of ever-burning lamps were common in the medieval world. Stories were told of tombs being opened after 1,000 years, only to find a lamp still burning inside, its flame as steady as the day it was lit. The Roman king Numa Pompilius was said to have one. A lamp was reportedly found burning in the tomb of Pallas, son of Evander, when it was opened in the 15th century. These lamps were seen as proof of ancient lost magic. The ability to create a flame that needed no fuel was the ultimate mastery over nature. It defied all logic. The magic was likely a combination of clever engineering and misunderstood chemistry. While a truly perpetual flame is impossible according to the laws of thermodynamics, it was possible to create a lamp that could burn for a very, very long time, long enough to seem forever to those who discovered it. There were two main secrets, the fuel and the wick. The fuel had to be very slow burning and sealed from evaporation. The best candidate was oil from crude petroleum seeps, which were known in the ancient world. If a large, sealed reservoir of this oil was connected to a wick by a tiny, slow-feeding tube, it could provide fuel for years or even decades. The key was to make the reservoir airtight so the oil would not evaporate away. The wick was even more clever. A normal wick made of cloth or plant fiber would burn away and need to be replaced. But what if you had a wick that did not burn? This is where a mineral comes in. Asbestos. Asbestos is a fibrous silicate mineral that is incredibly resistant to heat. It can be woven into a cloth-like material. An asbestos wick would draw up the fuel and allow it to burn, but the wick itself would not be consumed by the flame. It would glow red hot but remain intact. The ancient Greeks knew about asbestos. They called it amiantis, meaning inextinguishable. They used it to make funeral shrouds and reputedly lamp wicks. So a clever craftsman could construct a lamp with a large, sealed container of slow-burning oil feeding a non-combustible asbestos wick. Such a lamp, placed in a sealed tomb with a limited oxygen supply, would burn very slowly and efficiently. When the tomb was opened centuries later, the sudden influx of fresh oxygen could even cause the flame to flare up brightly before it finally exhausted its ancient fuel supply. To the discoverers, it would seem as if the lamp had been burning continuously the entire time. The science is material science and fluid dynamics. It is about choosing the right materials to resist heat and designing a system for slow, controlled fuel delivery. It is a brilliant piece of long-term engineering, not a magical flame, but questions persist. Were any of these ever burning lamps real? Or were they all just exaggerated stories? Did the alchemists who sought the secret of their construction ever succeed? And are any of their creations still burning, sealed away in some forgotten place? And what other impossible ancient technologies were simply based on a masterful understanding of the properties of natural materials? Number 11, could you capture a ghost in a box? Imagine being led into a darkened room. On a table, there is a small wooden box with a tiny hole in one side. The magician tells you he can capture the spirit of the world outside. He aims the box at a sunlit scene, perhaps a castle on a hill. You look at the wall opposite the box, and there, you see it. An image of the castle shimmering in the air. It is upside down and faint, but it is undeniably there. It is a ghost of the real world, captured and projected onto the wall. This magical device was the camera obscura, which is Latin for dark chamber. The principle behind it is one of the simplest in all of optics, but its effect is magical. The first clear description of it in the Western world comes from the 10th century Arab scholar Ibn al-Haytham. He used it to study the nature of light and prove that light travels in straight lines. By the late medieval period and into the Renaissance, knowledge of it had spread to Europe. Artists like Leonardo da Vinci wrote about it in his notebooks, and it was a popular tool for natural magicians. The science is beautifully simple. Light travels in straight lines. Imagine you are in a completely dark room or box. If you poke a tiny hole, a pinhole, in one wall, the light rays from the scene outside will pass through that hole. A ray of light from the top of the castle will travel in a straight line through the hole and land on the lower part of the opposite wall. A ray of light from the bottom of the castle will travel in a straight line through the hole and land on the upper part of the wall. Every point on the scene outside sends out rays of light in all directions, but only the ones that pass directly through that single tiny hole will make it inside. The result is a perfect but inverted projection of the outside world onto the inner wall. To an audience who did not understand how light worked, this was a profound mystery. It looked like the image was being magically peeled off the world and transported into the room. Giambattista della Porta, in his Magia Naturalis, suggested adding a lens to the hole to make the image brighter and sharper, and using actors outside to create little plays that would be projected to a stunned audience inside. He was essentially describing the birth of cinema. He was later charged with sorcery for his demonstrations. The camera obscura played on the fundamental mystery of vision itself. How do we see? How does the world get into our heads? The device seemed to offer a tangible answer, but one that felt supernatural. It was a box that could see. This leaves us with some big questions. Did ancient cultures discover the camera obscura principle by observing light filtering through a tiny hole in a tent or hut, and did they interpret the resulting images as messages from the gods? How much did the use of this device by Renaissance artists influence the development of realism and perspective in painting? And is our modern technology, which captures and projects images so effortlessly, just a very advanced version of this same simple, magical box? Number 10, how did they make invisible ink appear? A secret message must be sent. The messenger might be captured and searched. The letter must appear to be a blank piece of paper, or perhaps it is a normal letter with the real message hidden between the lines. The recipient receives the letter, they hold it over a candle flame, and as the paper heats up, dark brown writing slowly appears where there was nothing before. The secret is revealed. Invisible ink is a classic tool of spies and conspirators, but in the medieval world it was also a form of magic. The ability to make writing appear and disappear at will seemed like a command over the very substance of the page. It was a secret known to scribes, alchemists, and schemers. The magic is simple organic chemistry. The most common type of invisible ink used heat to reveal the message. The ink was an acidic liquid like lemon juice, vinegar, or even milk. These are all weak organic acids. When you write with them, the liquid soaks into the fibers of the paper. When it dries, it is invisible, but the acid is still there. It has weakened the paper fibers in the places where you wrote. When the paper is gently heated, the parts of the paper that were touched by the acid will burn or oxidize more quickly than the surrounding paper. The acid acts as a catalyst for the combustion, so the writing turns brown and becomes visible long before the rest of the paper gets hot enough to catch fire. The ancient Roman poet Ovid mentioned the idea of writing with milk in his Ars Amatoria as a way to send secret love letters. Pliny the Elder also described using plant juices for the same purpose. The knowledge was ancient, but it was often guarded. There were other methods as well. Some inks were developed using chemical reactions. For example, you could write a message with a solution of copper sulfate, which is nearly invisible when dry. To reveal it, you would expose the paper to ammonia fumes. The ammonia reacts with the copper sulfate to create a deep blue compound, and the message appears. This was a more advanced form of the trick, one that would be familiar to any alchemist working with metallic salts. This trick preyed on the idea that things can have hidden natures. A blank page was not always blank. It could hold a secret waiting for the right key, in this case heat or another chemical, to unlock it. It was a physical manifestation of hidden meaning, a powerful concept in a world that saw symbols and secrets in everything. But what don't we know? How many important historical documents contain secret messages written in invisible ink that we have not yet found because we have not used the right technique to reveal them? Did this simple trick ever change the course of a battle or a political succession? And in an age of digital encryption, have we lost the simple elegance of a message hidden in plain sight? Number 9. Could a potion really make someone fall in love? The love potion is a staple of folklore and fantasy. A few drops of a magical liquid slipped into a person's drink, and they will be hopelessly infatuated with the first person they see. In the medieval world, this was not just a fairy tale. Cunning folk, village healers, and apothecaries sold potions and charms that promised to win the affection of a reluctant lover. These were often a mix of superstition, psychology, and some very real pharmacology. The magic was a combination of the placebo effect and the use of psychoactive herbs. There was no single ingredient that could magically create the complex emotion of love. But a potion could certainly alter a person's state of mind, making them more suggestible, less inhibited, or simply feel different. Many so-called love potions contained ingredients that were known to have a physical effect on the body. Herbs like mandrake, henbane, and belladonna were common in folk medicine. We now know that these plants are powerful and dangerous. They belong to the nightshade family and contain tropane alkaloids like atropine and scopolamine. In small doses, these chemicals can cause flushed skin, a rapid heartbeat, and dilated pupils. These are all physical signs that we associate with excitement and attraction. A person taking such a potion would literally feel their heart race. Their brain might interpret these physical symptoms as the beginnings of love or lust. In larger doses, these same herbs are potent hallucinogens and deliriants. They could induce a state of confusion and heightened suggestibility. A person under the influence of such a potion might be more easily persuaded or manipulated. The love they felt might be a product of their altered mental state. Other ingredients might include mild aphrodisiacs or simply substances that had a reputation for power, like powdered gemstones or parts of animals. The other crucial ingredient was belief, the placebo effect. If both the person giving the potion and the person taking it believed it would work, that belief itself had power. The giver would act with more confidence. The receiver, told they were about to fall in love, would be looking for signs of it. They would interpret any friendly gesture, any stray glance, as proof that the magic was working. The potion became a psychological lubricant, allowing two people to act on feelings they might have already had but were too shy to express. It was a permission slip for romance. The science is pharmacology and psychology. It is about using chemicals to alter physiology and using belief to alter perception. There was no magic, but there was a very real effect on the body and mind. This raises some difficult questions. How many of the bewitchments that led to witchcraft trials were actually cases of surreptitious drugging with these powerful herbs? Did the healers who prescribed these potions understand the pharmacology, or were they just following traditional recipes without knowing the real risks? And in our own time, when we use chemicals like alcohol to lower our inhibitions, are we doing anything so different from the person who slipped a few drops of henbane into a cup of wine? Number 8, how did oracles and idols give advice? In a sacred grotto or a grand temple, a priest stands before a statue of a god or an oracle. A pilgrim asks a question about their future. The priest consults the idol. And then a voice seems to emerge from the statue itself. It is a booming, disembodied voice full of authority and otherworldly wisdom. The god has spoken. This was a trick as old as religion itself, and like the brazen head, the magic was almost always acoustics. But it could be done with surprising sophistication. The goal was to make a voice appear to come from a place where there was no person. The hidden speaking tube was the simplest method, but there were others. A skilled performer could use ventriloquism. The ability to throw one's voice is an ancient art. By speaking without moving their lips and using the resonant qualities of the room, a priest could make it seem as if their voice was coming from a statue, a tree, or a fissure in the rock. The word ventriloquism itself comes from the Latin for to speak from the stomach. In the past, it was not seen as a performance trick. It was believed that the ventriloquist was channeling a spirit that spoke from within their belly. The architecture of the room itself could also be part of the trick. Whispering galleries are a famous example. These are circular or elliptical rooms where the curved walls focus sound waves. A whisper spoken at one point on the wall can be heard clearly at another point all the way across the room, but not by people standing in between. The dome of St. Paul's Cathedral in London, built by Christopher Wren in the late 17th century, is a famous example. But the principle was known and used in antiquity. A priest could be hidden at one focal point of a sacred chamber and whisper the oracle's message, which would be heard perfectly by the pilgrim standing at the other focal point, seemingly coming from the empty air around them. Another technique involved using the natural resonance of large vessels. A large empty amphora or pot could be hidden behind or beneath a statue. If a person spoke into a tube that led into the pot, the sound would resonate and emerge with a deep, booming quality, making a human voice sound more like the voice of a god. The science is the physics of sound. It is about understanding how sound waves travel, how they reflect off surfaces, and how they resonate in enclosed spaces. The magic came from manipulating these principles in secret to create an effect that seemed to violate the normal rules of perception. But what do we still not know? Were some ancient temples like the Oracle at Delphi specifically designed with acoustic tricks in mind to enhance the authority of the priests? How skilled were ancient ventriloquists, and were they a recognized class of religious performers? And how much of our own experience in grand cathedrals or concert halls is shaped by the subtle, deliberate manipulation of sound by the architects? Number 7, could a person truly be immune to poison? The medieval and Renaissance courts were dangerous places. Political rivals, jealous lovers, and ambitious courtiers often resorted to poison. A king or a pope lived in constant fear of a tainted cup of wine or a poisoned plate of food. In this climate, anyone who claimed to be immune to poison or to possess a universal antidote would have immense power and prestige. The most famous were the snake oil salesmen of their day, known as charlatans, who would stage dramatic public demonstrations. In a crowded town square, the charlatan would have an assistant bring out a vial of deadly poison, often arsenic. They would show it to a doctor in the crowd who would confirm its lethality. The charlatan would then swallow the poison. The crowd would hold its breath, but the man would not sicken or die. He would smile, take a swig of his own special antidote, and then begin selling it to the amazed onlookers. The magic was a combination of chemistry, physiology, and outright fraud. The charlatan was not immune to poison. He was just very well prepared. There were several ways to perform this trick. One method was to build up a tolerance. This is a real but very dangerous physiological process called Mithridatism, named after King Mithridates VI of Pontus, who supposedly made himself immune to poisons by taking tiny, gradually increasing doses every day. It is possible to build up a significant tolerance to certain poisons, like arsenic, this way. The body adapts by producing proteins that bind to the poison and remove it before it can do damage. A charlatan might have spent years carefully conditioning his body to withstand a dose that would kill a normal person. A more common and less risky method was to cheat. The poison swallowed on stage was not what it seemed. A classic trick involved arsenic trioxide, a common poison. In its pure powdered form, it is highly soluble and deadly. But if it is mixed with charcoal and swallowed in a solid lump or capsule, it can pass through the digestive system largely unabsorbed. The charcoal, a form of activated carbon, would absorb much of the poison that did dissolve. Another trick was to swallow the poison and then discreetly induce vomiting a short time later before the poison could be absorbed into the bloodstream. The antidote was often part of the trick as well. Some were just colored water. But others, known as bezoar stones, had some basis in science. A bezoar is a hard mass of undigested material found in the stomach of an animal, usually a goat. It was believed to be a universal antidote. While it could not cure all poisons, a real bezoar is porous and composed of hair and minerals. It can act like activated charcoal, absorbing some types of poison, particularly arsenic. So, in some cases, the antidote might have actually worked, at least partially. The science is toxicology and physiology. It is about understanding how poisons are absorbed by the body and finding ways to prevent that absorption or condition the body to resist it. This leaves some nagging questions. How many of the charlatans who practiced Mithridatism died from accidental overdoses while trying to build their immunity? Was the trade in bezoar stones regulated, or were most of them fakes sold to desperate people? And what is the real biological limit of the human body's ability to adapt to toxins in our environment? Number 6, what was the ghostly light that danced over swamps? Travelers crossing a marsh or a bog at night would sometimes see a strange flickering light. A small, eerie flame, often blue or green, would appear to dance in the air just above the ground. It would hover, drift, and then disappear, only to reappear a short distance away. This was the will-o'-the-wisp, also known as ignis fatuus, which is Latin for foolish fire. Folklore said it was the spirit of a lost soul, or a mischievous fairy, trying to lead travelers off the path into their doom in the swamp. To see one was a terrifying omen. The magic was biology and chemistry, happening deep in the mud. The light was real, but it was not a spirit, it was burning gas. Swamps, bogs, and marshes are places where a lot of organic matter, dead plants, and animals decomposes. Because this happens underwater, or in waterlogged soil, there is very little oxygen available. This is called anaerobic decomposition. The bacteria that thrive in this environment produce methane gas, also known as swamp gas. It is the same natural gas we use for heating. They also produce other gases like phosphine and diphosphane. Here is the science. Methane is flammable, but it needs a source of ignition to burn. Phosphine and diphosphane, however, have a special property. They can ignite spontaneously when they come into contact with the oxygen in the air. So, when a bubble of this mixed gas rises up from the decaying mud and breaks the surface, the phosphine in it can instantly catch fire. This, in turn, ignites the methane. The result is a small, brief flash of flame. Because the gas is seeping up from different spots and is moved by faint breezes, the flames appear to flicker and move around. The cold flame quality and the blue or green color are characteristic of burning phosphine and methane. The phenomenon was first scientifically explained in 1776 by the Italian physicist Alessandro Volta, the inventor of the electric battery. He identified methane as the primary component of the gas. The role of phosphines was proposed later, in the 20th century, to explain the spontaneous ignition. Before this, the only explanation for a light with no visible source was a supernatural one. The will-o'-the-wisp played on a deep-seated fear of the unknown and the treacherous nature of the landscape. A swamp was already a dangerous place. The appearance of a mysterious moving light confirmed its evil reputation. It was a natural phenomenon perfectly suited to become a ghost story, but there are still things we do not fully understand. Is the phosphine theory the only explanation for the spontaneous ignition, or could other biochemical processes be at play? The exact conditions required to produce a visible will-o'-the-wisp are rare, and reports have declined in modern times. Is this due to the draining of wetlands, or is there another factor we are missing? And how many folktales around the world about elemental spirits are just misinterpretations of localized natural chemical reactions? Number 5. How could you make a golem from clay? The legend of the Golem of Prague is one of the most famous tales of Jewish folklore. In the 16th century, Rabbi Judalo ben Bezalel supposedly created a giant man out of clay from the banks of the Vltava River to protect the Jewish community from persecution. By placing a piece of parchment with the secret name of God, Hashem, in its mouth, he brought the creature to life. The golem was immensely strong and followed its master's commands, but it was a creature without a soul, and it eventually grew violent and had to be destroyed. This is a story about the awesome and dangerous power of creation, but the idea of animating the inanimate, of making a machine that moves and acts like a person, was not just a myth. It was the goal of a very real field of science and engineering, automata. The magic was mechanics and clockwork. The desire to create artificial life is ancient. Hero of Alexandria, back in the 1st century, designed elaborate automata powered by water, steam, and systems of weights and pulleys. He made birds that would sing and figures that would pour wine. In the medieval Islamic world, inventors like Al-Jazari in the 12th century created stunningly complex automata, including a peacock fountain with robotic servants and a musical band of robots that floated on a lake. His Book of Knowledge of Ingenious Mechanical Devices from 1206 is a testament to this incredible engineering. This knowledge slowly trickled into Europe. By the late medieval period and into the Renaissance, clockmakers were the most advanced engineers of their time. They could create intricate systems of gears, springs, and levers. While they were mostly making clocks, they sometimes used their skills to create automata. There were figures that would strike bells on the hour like the famous clock in Strasbourg Cathedral. There were mechanical monks that would walk and beat their chests. The Spanish clockmaker Juanelo Turiano supposedly built one for Emperor Charles V around 1560. These were not true golems, they were not made of clay, and they were not powered by divine magic. They were made of wood and metal, and they were powered by wound springs or falling weights. They could only perform a limited set of pre-programmed actions, but to a person who had never seen a machine more complex than a water wheel, a walking, moving figure that looked like a man, was a terrifying and magical sight. It blurred the line between the living and the dead, the natural and the artificial. It was a golem made real, not by Hashem, but by a gear train. The science is mechanical engineering. It is the art of translating stored energy into complex, controlled motion using a series of interlocking parts. The legends, like that of the golem, can be seen as a philosophical response to this emerging technology. They ask a question we are still grappling with today. Just because we can create something that looks and acts alive, should we? This leaves us with some profound questions. How much did the real-world existence of mechanical automata influence the stories and legends about magical constructs like the golem? Did an inventor like Al-Jazari see himself as an engineer or as a kind of magician who could breathe life into metal? And as we build increasingly sophisticated robots and artificial intelligence, are we simply continuing the work of these early clockmakers, still chasing the dream of creating a golem of our own? Number 4. Why did some people seem to predict the weather? A farmer looks at the sky and says, "Red sky at night, sailor's delight. Red sky at morning, sailor's warning." An old woman says her aching joints tell her a storm is coming. A sailor observes the behavior of a seabird and knows that land is near. In a world without meteorology, these people seem to have a magical sixth sense. They could read the future in the signs of nature. Their predictions were often uncannily accurate. Their magic was not clairvoyance. It was deep observational science. It was the practice of recognizing patterns in the environment that had been accumulated over generations. This was folk meteorology, and it was based on centuries of trial and error. The science behind these old sayings is often sound. Red sky at night, sailor's delight works because weather systems in the mid-latitudes generally move from west to east. A red sky at sunset means the sun, low in the west, is shining its light through a clear, dry atmosphere onto the clouds high in the east. This indicates that the weather to the west, which is coming your way, is good. A red sky in the morning means the sun in the east is shining on high clouds to the west, suggesting that a weather front and likely rain is approaching from that direction. The idea that aching joints can predict the weather also has a scientific basis. Before a storm, there's often a drop in barometric pressure. The air pressure pushing on our bodies decreases. For people with arthritis or old injuries, this change in pressure can cause the tissues and fluids in their joints to expand slightly, leading to increased pain and stiffness. The old woman was not feeling the future. She was feeling a present physical change in the atmosphere that was a reliable indicator of future weather. And animal behavior is another powerful predictor. Many animals are more sensitive to changes in air pressure and humidity than humans are. Birds might fly lower to the ground when air pressure drops because the thinner air at higher altitudes is more difficult to fly in. Bees might return to their hives and become more aggressive before rain. Observing these subtle changes in animal behavior was a reliable way to get a short-term weather forecast. This was a science of observation, not of theory. The farmer did not know about high-pressure systems or Rayleigh scattering, the phenomenon that makes the sky red. But he knew the pattern. Red sunset equals good weather tomorrow. That knowledge was vital for his survival. It told him when to plant, when to harvest, and when to bring the animals in. It was a form of science born from necessity. But what are the limits of this knowledge? How many folk sayings about the weather are pure superstition, like with no scientific basis at all? As we have become more reliant on technology for our forecasts, how much of this deep observational knowledge of the natural world have we lost? And are there subtle environmental patterns that traditional cultures understood that our modern science has yet to recognize? Number 3, how could alchemists turn lead into gold? This is the ultimate magical trick, the magnum opus, the great work of alchemy, to take a dull, cheap, common metal like lead and transmute it into the most precious, noble, and perfect metal of all, gold. For centuries, alchemists toiled in their laboratories, surrounded by strange vessels and cryptic texts, seeking the secret of transmutation. They believed that all metals were made of the same basic substance and were just in different stages of purity or ripeness. Lead was simply an immature, sick form of gold. With the right process and the right catalyst, with the legendary philosopher's stone, it could be purified and perfected. To the outside world, this was the height of sorcery. To change the very essence of a substance was to wield the power of a god. And sometimes it looked like they had succeeded. An alchemist might hold a public demonstration. He would take a lead coin, dip it in a mysterious liquid, and pull it out, now gleaming with a perfect layer of gold. He had done it, the magic was chemistry, but it was the chemistry of deception, not of transmutation. Alchemists never succeeded in turning one element into another. We now know that lead is element 82 and gold is element 79. To change one to the other, you would have to alter the nucleus of the atom itself, a feat that requires a nuclear reactor or a particle accelerator. But they were masters of chemical reactions that could create the illusion of transmutation. The trick with the coin was a classic. The alchemist might have started with a brass coin, an alloy of copper and zinc that already has a yellowish color. He could then treat it with mercury to create an amalgam that gave it a silvery, lead-like appearance. This was his lead coin. The secret liquid he dipped it into would be a strong acid, like nitric acid. The acid would dissolve the mercury off the surface, revealing the gold-colored brass underneath. To the audience, it looked like a transformation from silver to gold. Another method was simple electroplating, even without a battery. If you place a less reactive metal into a solution containing the salt of a more reactive metal, nothing happens. But if you place a more reactive metal like iron or zinc into a solution containing the salt of a less reactive metal like copper or gold, the more reactive metal will dissolve and coat itself with the less reactive one. An alchemist could create a solution of gold chloride. By dipping an iron nail into this solution, the iron would start to dissolve and a thin, real layer of gold would be deposited onto the nail's surface. It was a chemical exchange, not a transmutation, but the visual effect was the same. While they never achieved their ultimate goal, the alchemists were not failures. In their quest for the philosopher's stone, they laid the groundwork for modern chemistry. They discovered new elements like arsenic and antimony. They developed techniques for distillation, sublimation, and crystallization. They invented laboratory equipment we still use today. They were the first systematic experimental scientists. The science was metallurgy and solution chemistry. The magic was in creating a surface-level change that mimicked a fundamental one. This brings up some fascinating questions. Did the alchemists who performed these public transmutations know they were just tricks, or did they believe they were on the verge of the real thing and that these were just minor successes along the way? How much of the secretive mystical language of alchemy was designed to protect real chemical knowledge from rivals? And in their obsessive pursuit of an impossible goal, Did they accidentally stumble upon discoveries more valuable than gold itself? Number 2, how did a simple rod find hidden water? The scene is a familiar one from old pictures. A man walks slowly across a dry field. He holds a forked branch, usually from a hazel or willow tree, in front of him. His grip is tense. He walks back and forth. Suddenly, the tip of the branch dips down sharply, pointing toward the ground. He stops. "Dig here," he says. "A well is dug and water is found. The man is a dowser, and his forked stick is a divining rod." For centuries, dowsing has been used to find not just underground water, but also mineral deposits, lost objects, and even buried bodies. It was, and still is, seen by many as a magical ability, a special sensitivity to the hidden energies of the earth. The rod is just an antenna that amplifies the dowser's innate power. The church often condemned it as a form of divination that relied on demonic forces. But the magic is not in the earth or in the rod, it is in the dowser's own muscles. The phenomenon is a perfect example of what psychologists call the ideomotor effect. The name sounds complex, but the idea is simple. It is the power of suggestion to create involuntary, unconscious muscle movements. Here is how the science works. The dowser holds the forked rod in an unstable grip. The two forks are pulled apart, creating tension. It takes a very small muscle movement in the hands or wrists to make the point of the rod dip or rise dramatically. The dowser is not consciously trying to move the stick. In fact, they are consciously trying to hold it still. But their brain knows what they are looking for. They have an expectation. As they walk over a spot where they subconsciously believe water might be, perhaps because the vegetation is slightly greener, or there is a subtle dip in the land, their brain sends tiny involuntary signals to their muscles. Their hands tremble just enough to make the rod dip. Because the dowser is not aware of making this movement, it feels like an external force is moving the rod. It feels like the rod is being pulled down by some energy from the ground. The effect is powerful and convincing, both to the dowser and to anyone watching. The same principle is at work with a Ouija board, where the planchette seems to move on its own, or with a pendulum used for divination. The user's unconscious muscle movements, driven by their expectations, are creating the magic. The first detailed description of dowsing for metals appeared in Georgius Agricola's 1556 treatise on mining, De Re Metallica. He was skeptical, noting that it seemed to work only for certain people and not for others. Controlled scientific tests of dowsing have consistently shown that it is no more effective than random chance at finding water. When a dowser succeeds, it is usually because they are in a region where you are likely to find water if you dig almost anywhere, or because they are unconsciously picking up on real geological or botanical clues. The science is psychology and physiology. The magic is the brain's remarkable ability to fool itself. But this raises some deep questions about the mind. How powerful is the ideomotor effect, and what else does it influence in our daily lives without our awareness? If a dowser finds water through a combination of unconscious observation and the ideomotor effect, does it matter that the magic is not real? And could this effect be harnessed for other purposes, to tap into our own subconscious observations about the world around us? Number 1, what made ghostly flames dance on a ship's mast? Imagine you are a sailor on a wooden ship in the middle of the ocean. A fierce storm is raging. The wind howls, the waves crash over the deck. It is a terrifying, chaotic scene. And then you see it. A ghostly bluish white flame appears at the very tip of the ship's mast. It flickers and dances, but it does not burn the wood. Sometimes a second one appears on another mast. The crew stops in their tracks, staring up in awe and fear. Is it an angel, a demon, or the soul of a drowned sailor? This was St. Elmo's fire. For thousands of years, it was one of the most mysterious and sacred phenomena witnessed at sea. The ancient Greeks called them Helen and Castor and Pollux. To medieval Christian sailors, it was the physical manifestation of their patron saint, Saint Erasmus of Formia, whom they called Saint Elmo. They saw it as a good omen, a sign that the saint was watching over them, and that the worst of the storm was over. Julius Caesar and Ferdinand Magellan both reported seeing it in their logs. The magic was atmospheric physics. St. Elmo's fire is not fire at all. It is plasma. The same state of matter found in lightning, the stars, and neon signs. The science behind it is all about electricity. During a thunderstorm, the air becomes electrically charged. A huge potential difference builds up between the storm clouds and the ground, or in this case, the sea. The ship, being on the water, becomes a sort of electrical conductor, and a ship's mast is a tall, pointed object. Electrical charge tends to concentrate at sharp points. This creates an incredibly strong electric field right at the tip of the mast. The field is so intense that it starts to tear electrons away from the nitrogen and oxygen molecules in the air. This process is called ionization. The result is a cloud of charged particles, a plasma surrounding the masthead. When the electrons recombine with the ionized molecules, they release their excess energy in the form of light. The color of the light, usually blue or violet, is the characteristic emission spectrum of nitrogen and oxygen gas being excited in this way. It is a type of corona discharge, a continuous electrical spark. It is completely silent, or it might be accompanied by a faint hissing or buzzing sound. And because it is a relatively low energy plasma, it is not hot enough to set the wooden mast on fire. It is a cold light. It was a perfectly natural, if rare, electrical phenomenon. But in an age that had no concept of atoms, electrons, or electric fields, it could only be interpreted as a supernatural event. It was science acting on a grand and terrifying scale, creating an effect that was indistinguishable from a miracle. And even now, knowing what it is, some questions remain. Can we precisely predict the atmospheric conditions that will create St. Elmo's fire, or does it still retain an element of unpredictability? Does the exact color of the plasma give us detailed information about the composition of the air in that specific location and moment? And how many other historical accounts of ghosts, angels, and spirits were simply people witnessing a rare and beautiful display of the laws of physics that they did not yet have the words to describe?